Okay, hello girls. In earlier PPT, we have gone through the critical section, context switching, and rest around condition that is related to process synchronization. Now, when we are talking about multiprocessor and one uniprocessor system, in uniprocessor system, when a number of processes are to be handled, synchronization is important. That is to avoid rest around condition. For uniprocessor system, when shared resources are there, those should be kept in critical section, and unshared resources can be kept in non-critical section. Now the mechanism to manage critical section is important. It can be managed by entry section or exit section, which acts entry gate and exit gate for the particular critical section that we have already seen in last slide. Now to handle critical section in normal program, few lines of code which are considered as entry section should be written. Same way, at the end of critical section, few lines of code those are considered as exit section must be written. So for process can enter into critical section unless it executes entry section, and cannot come out of it unless it executes exit section. Now talking about different process synchronization methods, roughly there are three process synchronization mechanisms or the solutions available: a semaphore, Peterson solutions, and a locking method. But before talking about synchronization mechanisms, there are four rules to be followed by a mechanism for synchronization to be developed. Now there are certain solutions available, but one can write its own solution, but it should follow the rules given over here. So what are those rules? So before going to those rules, let's talk about a critical section problem. So we know what is critical section. So if multiple processes tries to access the critical section concurrently, then the results produced might be inconsistent. So this type of problems are called as critical sections. Now talking about synchronization mechanism, what is synchronization mechanism? It allows the process to access critical section in synchronized manner so that the inconsistency can be avoided. Now for every critical section, there is entry section and exit section, as we know. So what is entry section, what is exit section, we have already discussed. So now next part is what are the criterias or the rules to those should be followed by a synchronization mechanism. There are four rules: mutual exclusion, progress, bounded wait, and architectural neutral. So the first rule is a mutual exclusion. So what is mutual exclusion? If there are two processes P1 and P2, both tries to enter into critical section, hope P2 won the race and executed intersection and enters into the critical section, then P1 should not be allowed to enter into the critical section as P1 is already using it. So P2 can lock the entry to critical section for other processes when it is using the critical section, when it enters into the critical section. So it is called as a mutual exclusion. So how it is given? So we have to develop a synchronization mechanism so that it can ensure the processes access the critical section in mutual exclusive manner. Only one process is present inside the critical section at one amount of time, and no other processes can enter in the critical section until the process already present inside it completes the task. Now second rule is progress. So what is progress? Again, for two processes, suppose P1 and P2 are the two processes. If none of them is in critical section, that is now critical section is empty, no process is there inside that critical section. But after some time, P1 needs to use critical section and P2 does not allow it to enter into the critical section. Not because P2 is already using it, but just to hold the progress of P1, it is not allowing P1 to enter. For this, entry code of P2 is written purposely so that it can block P1 from entering into the critical section. Okay, so this is what affecting the progress. So this happen vice versa also, that is affecting the process of each other. P1 can block entry of P2 into critical section, or P2 can block the entry of P1 into the critical section. It is affecting the progress of both of the processes. Now the difference is in mutual exclusion. If particular process enters into the critical section, it locks the entry to other processes. And in progress rule, if a particular process enters into the critical section, it blocks purposely the entry of other processes into the critical section. So what should it ensure? When we develop a mechanism, entry of process inside the critical section is not dependent on the entry of another process. A process can freely enter inside the critical section if there is no other process present inside it. A process enters the critical section only if it wants to enter, and a process is not forced to enter inside the critical section if it does not want to enter. That means anyhow the progress of a particular process should not be affected by any other process by blocking the process from entering into the critical section or forcefully allowing that process to enter into the critical section. Now next rule is a bounded wait. So what is bounded wait? The bounded wait is, suppose there are number of processes, everyone is asking to enter into the critical section, every process should get a chance. Now it is possible that process 1 enters into the critical section, process 2 is waiting waiting for process P1 to complete its task, and at the time of waiting P1 completes this execution and again immediately it goes back and again enter into the critical section. This is happening again and again for n number of times, and for that amount of time P2 has to wait. So the waiting period of P2 is the larger. So it is also possible that you have to write a mechanism such that a particular process P1 is going on into the entry section again and again for infinite number of times, and for that amount of time P2 is still waiting and he is not getting his chance to enter into the critical section. So here P2's progress is holded. So the consider two processes P1 and P2. P2 is in critical section. P1 is in critical section. P2 is waiting for its turn to enter into the critical section. P1 exits from critical section, again enters back into the critical section, forcing P to wait again. Likewise, this is continuing till n number of times, and P2 has to wait and it is not getting any chance. So this condition is called as starvation. So this is important. Starvation means a particular process is waiting for infinite amount of time and some other process is getting chance for n number of times, holding or the forcing some other process into a starvation period. So solution should be designed such that P2 should get at least one chance after few number of chances given to P1. That is called as bounded wait. So that wait or the waiting amount should be bounded. That means this much is the amount or the maximum amount for which process P1 can get the chance to enter into the critical section and P2 has to wait. So what it should ensure? What do you mean by bounded wait? The wait of process to enter the critical section is bounded. The process gets to enter the critical section before its wait gets over. So the amount of time it has to wait, that is called as bounded wait. Now the next rule is architectural nature, architecturally neutral. So the solution should be designed such that it should be generic. It should not be dependent on the hardware configuration, operating system, or any other software or system software, anything. So it should be neutral, and it can work with the same capacity or any of the machine. That is, it should ensure that it can run on any architecture without any problem. There should not be dependency on the architecture. That means the solution should be generic, that should be portable and universal. So to make a note while designing a particular synchronization mechanism, amongst these 4 rules, first 2 are mandatory, that is those must be followed. Then only we can think about the rest of the rules. That is, the first 2, mutual exclusion and the progress, are mandatory criteria. They must be fulfilled by all the synchronization mechanisms. Regarding rest of 2, that is bounded wait and architectural neutrality, are the optional one. However, it is recommended to meet these criteria if possible. So this is about the rules. So we'll talk about the synchronization mechanisms in next PPT. So go through this and try to understand what is mutual exclusion, what is progress, what do you mean by a critical section, race condition, and Context switching. So we have already seen context switching in detail with respect to context uh, table, right? So just go through it into the detail and try to understand it. In next lecture or next PPT, we'll go through the different mechanisms for synchronization.